All right, today we're going to be talking about compound inequalities. Compound inequalities just means that we've got two inequalities just kind of like squished together. They're both on the same number line, and they come in two varieties. There are two types of compound inequalities. So you're going to have an inequality. Oops, that's an arrow of some kind. Okay. You're going to have an inequality that's going to do something like this. So it could be going opposite directions. Okay? And those are what we call the OR compound inequalities. It's either going this direction or it is going this direction. Okay? The other type you're going to see is you're going to have a number line like this, and they are going to both kind of meet in the middle here, and these are what we call our AND compound inequalities, and they just kind of form a bridge. These are where we get kind of our closed intervals or line segments or whatever you want to say. Okay, so these don't have any infinities at all when you have an AND. These have two. Okay, and you're going to love writing interval notation for that. I'll get to that in a second. Okay, so let's look at a couple of these. Now, first, before I get started, there are two types of compound AND inequalities. They'll either say AND, like this one, or it'll be set up like this one right here. Okay, those are both types of AND. Okay, ORs will always say OR. It's just how they're set up. Okay. Now let me start with the OR one here. So as you'll notice, we basically have two different inequalities, and we're just going to treat them like two different inequalities and just solve them and then graph them both on the same number line. Okay, so if you notice, these are both just one-step inequalities, so let's just hurry and solve them. So m minus 2 is less than negative 8. You're going to add 2 to each side, and you're going to get m is less than negative 6 for one of our inequalities. Okay, and then the other one, m over 8 is greater than 1. You're going to multiply each side by 8, and you're going to get m is greater than 8 for our other inequality. So I've got my two solved inequalities. Now I'm going to graph them. Alligator's eating the negative 6, so at negative 6, that means our variable is less than negative 6. So I'm going to put a open circle at negative 6, and this is going by 2's if you'll notice. So I put an open circle right there between negative 4 and negative 8. And it is less, so it's going to go to the left there. Okay. The other inequality is greater than 8. So again, regular inequality, open circle. It's greater than 8, so it's all those numbers that are to the right. Okay, so now I've got my graph. Now I need to do my interval notation. Now here's the thing you guys are going to love about the OR compound inequalities is we have one interval here and then a break, and then we've got another interval. So I'm actually going to have to write two different interval notations because I've got two different intervals. Okay, so you just write each interval notation separately. So, and again, order matters. You have to do the least interval first. Least number, greatest number, and then there's a symbol you have to put for OR inequalities, and I'll show you that in a second. And then again, least number, greatest number. Order matters. Don't do these out of order. You're going to get them wrong. Okay? So when we look at this one, the least number in this interval is negative infinity, right? Greatest number is negative 6. Okay? Infinity always has a parenthesis. Negative 6, that's an open circle. It's not actually equal to, so it has a parenthesis as well. And then because these are part of the same problem and they're on the same number line, we got to show that they are, combined. They're part of the same problem. So to do that, we put a U between our two interval notations. So you're just always going to have a U next to each interval. And then you put a parenthesis because this is, again, not equal to, and you're going to put an 8, and then an infinity, and another parenthesis. Okay? That's what you do with an OR. Now let's look at the ANDs. So the ANDs, so again, two different varieties. This one you would solve just kind of like the OR, solve them individually, and then, graph them, and they should be meeting the middle because it says and. Now this one, though, is combined in a way already. So what we have to do on this one is we've got to kind of separate it. And basically what it's saying is that this middle part is going to each inequality. So to separate it, you just kind of think of it like you just cross or put your finger over like one of the inequality sides and just pretend like there's one inequality. Again, that entire middle is going to go to each side. So I'm just going to rewrite it as two different problems right now. So I'm going to rewrite the top one. So we got -1 is less than 9 plus n, and I'm going to cross out the left one here. 9 plus n is less than 17. Okay? And that's probably just good practice to do, is that way, because a lot of times students will get stuck because they'll minus the 9 and then just get lost because they only did it to one side and whatever. So first thing you do is you separate those into two different inequalities. Then you're just going to solve them. So -9 to each side here, and again you're going to -9 to each side on that side as well. So over here you're going to get -10 is less than n, and then over here you're going to get n is less than 8. Okay, so basically saying, well, let's put our circle. So over here it's eating the n, so that means n is greater than -10, right? So we're going to put an open circle there because it's a regular inequality symbol, and it's going to be going to the greater direction, right? Notice how I kind of stopped because, again, ands, what are they going to do? They should meet in the middle when all is said and done. And over here it's eating the 8, so that means n is less than 8. So again, I put an open circle there, and it's going to be all these numbers that are less than 8. So there's our whole interval right there. Now with and compound inequalities, I can see the least number and I can see the greatest number. So it should not be a surprise what your least and greatest number is, because it should be what you just graphed, right? They're right there. Now to write it down, again, least number goes first, so -10. Greatest number goes last, so 8. Do they equal either one? Nope. So they're both going to have parentheses. Okay? And that's all you have to do for the interval notation there. So there's no infinity there. Hooray, you found one that didn't have an infinity, right? So let's look at another one. Let's do one a little bit more advanced. So let's come down here to number 8. And first of all, this is a OR. So what should it look like when it's done? It should look like this, right? Okay. Now, if you ever find you did one, and it does something like this, where you've got two lines going the same direction, you did something wrong. That is never ever going to happen. It's either going to do this or it's going to do this. Never this. Never ever. You did something wrong. Okay? So let's look down here at number 8. So it's OR. So again, it should be looking like this. So let's try and solve them. Again, I got two different equations or inequalities here that I'm going to solve. So let's start with the left one. It's just a party problem. Best friend acquaintance. Acquaintance is going to leave first, so we -3b to each side. Gives me -10b is less than or equal to -40. And then I divide each side by a -10. And then warning, what's happening here? I'm dividing to each side, and is my number negative? Yes, it is. So that means that my inequality symbol is going to flip, and b is going to become greater than or equal to +4. Okay? So there's one of my solved inequalities. Now let's look at the other one. So this one, I'm adding 10 to each side. Okay? So it's out the door, and then I'm left with 3b is less than or equal to -15. And then I divide by 3. Is that a negative number I'm dividing to each side? No. It's not, right? So my inequality symbol is going to stay the same. So b is going to be less than or equal to -5. Okay? So then when I graph these, b is greater than or equal to 4. So at 4, it's got that equal to, so it's going to be a closed circle. And it's eating my b, so that means it's all the numbers that are bigger than 4. So it's going that direction. And then at -5, it's eating the -5. So again, closed circle. Eating the -5 means it's less than -5, so it's going that direction. Okay, to the left. It's all those numbers that are left of it. Then I've got to do my interval notation. So again, order matters. I do my least interval first. Okay? Again, it should look like this if you were to read interval notation. Least to greatest. Notice how when I read this, it's the least number to the greatest number. You read from left to right. It should always be least to greatest. Okay? So looking over here, least number on this interval is -infinity, right? Greatest number on the interval is -5. And then it would have a parenthesis next to the infinity, but it's a closed circle. It's got that little line underneath it, right? So we're going to put a bracket at the -5 and then a u, saying they're on the same interval, inequality, same problem. And then we've got the 4 as the least number on the next interval, and then infinity. And again, the 4 is going to have a bracket, and infinity would have a parenthesis. Okay? Again, reading from left to right, least number, greatest number, least number, greatest number, yeah. Those are all in order, right? If I was to look at a number line, that's what I would see as my intervals. Okay? Make sure you write these from least to greatest. Okay, and that is how you do the compound inequalities.